If f of x equals x plus the square root of 2 minus x, and g of u equals u plus the square root of 2 minus u, is it true that f equals g? Let us solve this step by step. Two functions are considered equal if and only if two conditions are met. The formulas are the same, and the domains are the same. First, notice the two functions have the same formula. Both add the input variable to the square root of 2 minus that variable. The only difference is the variable names, x for f and u for g. Variable names are just placeholders and do not change the function's definition. Next, let us check the domain, or the allowed inputs. For both functions, the expression inside the square root must be greater than or equal to 0. That means the variable must be less than or equal to 2. So, both functions have the same domain, all numbers less than or equal to 2. Since the formulas and domains are identical, the functions f and g are equal. This question teaches us how to read the function graph. The graph of the function f is shown. For part A, we are asked to find the value of f of 1. To do this, we locate x equals 1 on the horizontal axis, move straight up to the graph, and read the corresponding y value. The point is at the top of the curve, which has a y value of 3. Therefore, f of 1 is 3. For part B, we estimate the value of f of -1. We locate x equals -1 on the horizontal axis and move up to the curve. The point lies slightly below the x-axis, about halfway between 0 and -1. Therefore, f of -1 is approximately -half. For part C, we are asked to find the values of x for which f of x equals 2. This means we look for where the graph crosses the horizontal line y equals 2. The graph intersects this line at x equals half, and again at x equals 2. Therefore, f of x equals 1 when x is half, and 2. For part D, we estimate the value of x such that f of x equals 0. This occurs where the graph crosses the x-axis. From the graph, the curve crosses the x-axis slightly to the left of 0, at about -half. Therefore, x is approximately -half. For part E, we state the domain and range of the function. The domain is all x values for which the graph exists. From the graph, this is from -2 to 3. The range is all y values the function takes. The lowest y value is about -1, and the highest y value is 2. For part F, we determine where the function is increasing. The function is increasing where the graph rises as we move from left to right. This happens from x equals -2 to x equals 1. Therefore, the function is increasing on the interval from -2 to 1. The function is defined as 3 times x squared minus x plus 2. We are asked to find the value of the function for different inputs by substituting those inputs wherever x appears. Now we begin solving step by step. First, we find the value of the function when x equals 2. To do this, we replace x with 2 everywhere in the function. We square 2, which gives 4. We multiply 3 by 4, which gives 12. Then we subtract 2. After that, we add 2. The final value is 12. So the value of the function at 2 is 12. Next, we find the value of the function when x equals -2. We replace x with -2 everywhere in the function. -2 squared is 4. We multiply 3 by 4, which gives 12. Subtracting -2 is the same as adding 2. Then we add 2 again. The final value is 16. So the value of the function at -2 is 16. Next, we find the value of the function when the input is a. We replace x with a everywhere in the function. The result is 3a squared minus a plus 2. Next, we find the value of the function when the input is -a. We replace x with -a everywhere in the function. -a squared becomes a squared. Subtracting -a becomes adding a. The result is 3a squared plus a plus 2. Next, we find 2 times the function of a. We start with the expression for the function of a. Then we multiply every term by 2. This gives 6a squared minus 2a plus 4. Next, we find the function of 2a. We replace x with 2a everywhere in the function. 2a squared becomes 4a squared. We multiply 3 by 4a squared. Then we subtract 2a and add 2. The result is 12a squared minus 2a plus 2. Next, we find the function of a squared. We replace x with a squared everywhere in the function. A squared squared becomes a to the 4th power. The result is 3a to the 4th power minus a squared plus 2. Finally, we find the square of the function of a. This means we take the entire expression for the function of a and multiply it by itself. We multiply each term in the first expression by each term in the second expression. After multiplying, we combine all like terms. The final simplified result is 9a to the 4th power minus 6a cubed plus 13a squared minus 4a plus 4.
First, recall the meanings of even and odd functions. An even function gives the same output when the input is changed to its negative. An odd function gives the opposite output when the input is changed to its negative. Next, consider the given function, which is multiplied by the absolute value of case. Now replace x with -x in the function. This becomes -x multiplied by the absolute value of -x. Remember that the absolute value of -x is the same as the absolute value of x. So the expression simplifies to -x multiplied by the absolute value of x. This result is the negative of the original function. Since changing x to negative x produces the opposite value, the function is odd. This is a piecewise function. It is a function defined with multiple functions with different domains. To evaluate a certain output, we look at the value and assign it to the correct domain. To evaluate f of -3, since -3 is smaller than -1, we'll use the first formula x plus 1, which equals -3 plus 1, which is -2. Now to evaluate f of 0. Since 0 is greater than -1, we'll use the second formula x squared, which equals 0 squared, which is 0. Now to evaluate f of 2. Since 2 is greater than -1, we'll use the second formula x squared, which equals 2 squared, which is 4. Now write in comments the value of f of -1. Subscribe for more. To find the domain of any function, think of it as the all possible values that make the function work without breaking any math rules. In this problem, we have two square roots. We have to ensure that each square root only accepts non-negative values. The inner part of the function is square root of p. For this to be a real number, the value inside must be 0 or positive, so p must be greater or equals to 0. The entire expression inside the big square root must also be 0 or positive. This means 2 minus square root of p must be greater or equal to 0. By solving this inequality, we find that p should be smaller or equal to 4. By combining the two intervals results, we find that p should be between 0 and 4. Why we included 4 and 0 in the solution interval? Write in the comments. The composition of functions is the process of combining two or more functions so that the output of one function becomes the input of another. In this question, we are asked to find f after g after h, which is equivalent to f of g of h. Let's start by evaluating the term after g of h. This means we apply the function h into the function g by replacing each x in g. By sine x, we got sine of squared x. Next, we apply the result into the function f of x. By replacing each x in f with the term sine of squared x, we got 3 sine x squared minus 2. So the final result is 3 sine x squared minus 2. Now can you evaluate h after g after x? To prove this equation, let's recall inverse function definition. An inverse function is a function that undoes the action of the original function. In general, f inverse of f of x is x and vice versa. This means the original function and its inverse cancel each other out. Now, let's assume theta equals sine inverse of x. By definition, that is equivalent to x equals sine a theta. By putting 1 in denominator, and recall that in right triangle, the sine is opposite divided by hypotenuse. Now, let's construct our triangle. We know all the sides except the adjacent. To find the adjacent, we will use Pythagorean. Solving for the adjacent equal negative or positive, the square root of 1 minus x squared. We'll neglect the negative value and put the value on the triangle. Now, to find cosine of theta, we will divide the adjacent by the hypotenuse, which is equal to the square root of 1 minus x squared divided by 1, which is square root of 1 minus x squared. Now can you write in comments why we neglected the negative value? In this lesson, we'll learn how to find the results of telescoping product of logs. First, recall the change of base rule for logarithms. Log base a of b can be written as the logarithm of b divided by the logarithm of a. Using this rule, each term in the product is rewritten. Log base 2 of 3 becomes log of 3 divided by log of 2. Log base 3 of 4 becomes log of 4 divided by log of 3. This pattern continues until the final term, which is log of 32 divided by log of 31. Now multiply all the fractions together. All the logs in the middle cancel out. Log of 3 cancels, up to the log of 31. After all cancellations, only log of 32 remains in the numerator, and log of 2 remains in the denominator. This is equivalent to log base 2 to 32, which is equal to 5, since 2 to the power 5 equal 32.